Welcome to the module demonstration for the scoping or the estimation module. GRC Perfect supports primarily three estimation methods. One is function point, one is use case point, and one is simple, medium, and complex. So let me start with the simpler one, which is simple, medium, complex. Go to use case point and function point in a demonstration manner. So to add any estimation, you just click on add. So you get the name. So for example, I'm going to do it as GRC Perfect SMC. SMC stands for simple, medium, complex estimate. And I select the estimation method as SMC. And then I also put estimation prepared by, and I can put reviewed by later on. So the moment I put my SMC method, I have a grid which is coming down below, which basically puts component wise distribution. So I can say that I have a login screen and estimated complexity is medium or simple, rather put it as simple. Then I have a schedule module, schedule page, which is very complex, and then I have a defect page which is complex. Like this I can keep adding components, and I can just say save, and then what it does is it puts overall indicating in the beginning the actual complexity would be same as estimated complexity, but you can change it later on. So suppose for example we started believing that the login is very simple, but it actually turned out to be a medium complex page, and the defect also we thought it's very complex but happened to be a medium complex one. So I just say that and I say save. You see the overall estimate for the project keeps changing. So we have 5 category of complexities defined in the tool, which is very simple, medium, complex, and very complex, which typically indicates the amount of time and effort taken to complete a particular task. All estimations can be submitted for approval, but I'm not going to demonstrate the approval cycle in the demo. We'll just keep it simple at this point in time to create and record estimates. So I have just shown you an SMC estimate. Similarly, I can create a GRC Perfect UCP estimate. So I am just going to make it as UCP estimate, and then I can select, sorry, I missed it. It is UCP estimate. The estimation method matters, so I'm just putting it as UCP. And as I do that, I also see a component coming. Basically UCP has 2 primary ways to compute. One is actor and use case. So I just say actor is a application user. Then we have another actor called super user. We have a use case called login. So we can define all these things. Actor, application user is a complex actor, super user is a very, very complex actor, and login is a medium complexity use case. So I do all that and I say save. So if you see in the database behind, if we had computed properly, we would have got the estimated size. Since there is no number associated with very complex actors, so it's not showing it. So for the time being, I'm just making it as complex. So it says based on this, your project size is about 30 use case points, and we keep adding these components, and later on we can actually change the actual complexity to say it could be medium, and it could be medium, and it could be simple or something like this, and then it also changes the actual size as we move in the project. It also has a factor built in called adjustment factor. So we can go on adjustment factor, and if we would have defined a proper checklist, it will also show you that the adjustment factor is so and so, and then the achieved score would be changed, adjusted size would be changed and shown with respect to the UCP estimate. So basically we have an unadjusted size, an adjustment factor, and all that put together makes it unadjusted size. And then based on the past productivity that we have seen, suppose we have seen past productivity of 30 UCP per month. So we just say that, and it changes saying that you need about 24 FTE resource if you have 1 month schedule. Suppose this is a 6 months project, I put it as 6 months, and it says you need about 4 resources to do this work. The problem in this demo is the adjustment factor, which is coming very high. Adjustment factor will typically be somewhere between 0.5 to 1.5. It will not be so high like 23.6 as it is showing here. So this basically shows how a UCP estimate is prepared in the tool. We also can prepare a function point estimate. So I'm just going to give you a demo for FP estimate. So I select it as FP and I save this. So now you will see the various component types. So I can take the component name as the login page, and if it is ILF and with an estimated DET and RET. DET and RET are basically a number of elements that exist in the data set. So this would require some amount of training on function point for somebody to understand how many DETs and RETs actually exist in the screen or report or the database diagram. That requires some amount of training, so I'm not getting into that. But basically the tool has a backend engine to compute function point based on the DETs and RETs provided by the team. Similarly, it also has an adjustment factor built in. So we can define an adjustment factor like we did for UCP, and it will actually change the total estimated size based on the adjustment factor. So now right now the adjustment factor is 0.65. So from an unadjusted size of 5, it has made an adjusted size as 3 because it multiplies 5 into 0.65 and makes it as 3. So based on all that, it says that maybe a 0.3 FTE is good enough to do this small task or project.